Let's do section 9.7. Section 9.7, okay? All right. Let's solve exponential equations and logarithmic equations, okay? Exponential equations is this, look. Exponential equations, we have 5 to the x equals to 125, okay? You can solve this one in two ways, okay? If you recognize this is an exponential equation, if you recognize it, if you can express both sides with the same base, it's an easy problem. In this case, we can. So look, this is 5 to the x equals 2, and this is 5 to the third. And whenever you have an equation and the left-hand side and the right-hand side both have the same base, you have no choice but to say that this can only be true if the powers are equal. Because we have the same base, this power x must equal to the power 3. Okay, and there we go. Now this is if you recognize it. Now there is a general way. A general way. If you don't recognize this, if you have 5 to the x equals to 125, okay, let's solve this without even worry about to see if you can express this right-hand side with the same base. Well, look, to solve this, the power must come down. Power down. Power. Down. Gotta bring it down if you're gonna solve. The way to bring it down is by taking the log of both sides. Yeah. Let's take the log of both sides. Which log? It's up to you. Theoretically, any log. You can use log base 10. You can use log base e. You can also use log base 5. Let's use log base. Let's use log base 10. Okay? Log base 10. That's the common log. Log, whenever the base is 10, you don't have to show it, but I'm going to show it to you guys, okay? So right now I'm going to write base 10, but in the near future you don't have to write base 10. So base 10 of 5 to the x equals to log base 10 of 125. There's a rule that says, one of the rules, that this power can come down and become a coefficient. So this x log base 10, I'm not going to write it because you don't have to. Of 5 equals log base 10. And you see this 125, I'm going to say 5 to the third. And just like this power came down, you can also bring this power down. It's gotta be the power of the argument of the log. Okay? So therefore, let's bring this power down. So look, x log base 10 of 5 equals 3 log base 10 of 5. So the rule, this rule, log base k, base x of k equals to the k comes down, k log base 10 or base b, okay, base b of x. That's what I used. And now, because I want to solve for x, let me get rid of log of 5. Log of 5, it just happens to be a number. It's a decimal. I'm going to tell you what it is. Okay, but you don't even have to know that. Okay, watch this. I'm going to tell you what it is. So, log 5, here is 5. Let me press log. I get 0.69. Actually, I get 0.7. I get 0.7. So this is 0.7. 0.7, okay? But you don't have to worry about that right now. Just divide it, okay? Just divide both sides by 0.7 or log of 5. So divide this by log of 5. Divide this by log of 5. All right, good class. And you see, this one cancels that one. This one cancels that one. And guess what, good class? X equals 2, 3, just like before. You understand what I'm saying? Listen, whenever you have to solve for an exponential equation, the power must come down. That's why I say power down. This power needs to come down. Don't forget that. Okay? So here's another one. Let's solve another one. Look, if you cannot express both sides with the same base, no problem. You can still solve it. Okay, so let's do another one. Let's solve this other one. Look at this. Let's solve. Let me solve. Here's a good one. Three to the x minus 2 equals to 4. There you go. You see? To solve this, what must you do? Power down. Because the power happens to be a binomial. When you bring it down, the entire binomial is going to come down. So power down. Okay? All right, so let's solve. Oh, I erased that. I've erased power down. I don't want you to forget that, okay? Power down. So let's bring the power down. And how do you bring the power down? Well, let's do it the general way. Take the log of both sides. Okay? Listen, guys. Earlier, I could have used log base 5. I could use any log, any base, as long as the base is greater than 0, not equal to 1. I can use any base I want. But the two convenient logarithms are log base 10 or log base e. Those two are the convenient ones. Okay, I like log base e, the natural log. I like that one. It's just easier to write. It's one letter less than log base 10. Why? Because log, you say L-O-G, and ln, just ln. But hey, it doesn't matter. In fact, I'll do it both ways. Watch this. I'm going to take the ln. So ln of 3 to the x minus 2 equals to ln of 4. Remember what I said? Power down. Come on, you come down. The only way to bring it down is by doing what I just said. Take the ln. When you bring it down, because these two is a binomial and they go together. Those two go together. When you bring it down, you better bring it down within parentheses. If you do not bring it down within parentheses, you're gonna make a huge mistake. Power come down. So therefore, you better do this. Parentheses, x minus 2, close parentheses, ln of 3 equals to ln of 4. And now you have a choice. Okay, you have a choice now. If you want to, you can divide both sides by ln of 3. Divide this side and this side by ln of 3 because it's got to be the same thing. This ln of 3 cancels. This ln of 3 cancels this ln of 3. Cancel. And we get x minus 2 equals 2. And I'm just going to say ln of 4 divided by ln of 3. Don't forget, that's a decimal and that's a decimal. So this together is a decimal divided by a decimal. And now let's solve for x and bring the negative 2 to the right. And so therefore, x equals to 2 plus ln of 4 divided by ln of 3. And my suggestion is that you do not transform this into decimals until you get to the end. Now that we got to the end, this is the exact answer. This is exact. I think this is the way you spell exact answer. If you want to approximate the answer, well then you better use your calculator. X equals 2, and your calculator, you better use it. Okay, I think let's connect this now. So in my calculator, I don't know about your calculator, but my calculator, I better do the ln first. Okay, so I'm gonna say ln of 4, whoa, hold on, relax. 4 ln divided by 3 ln, you better say equal, and you better say plus 2, and then equal. I get 3.26. Okay, I'm gonna do one more time. 3.26. Okay. Do it again. So I'm gonna say 4 ln divided by 3 ln, okay, you better say equal, and plus 2, plus 2, and I get 3.26, Let's do another one. Let's do another one. Yeah. Here is another one. Here's one more. Okay. Watch this. 7 to the x minus 1 equals 3 to the x plus 2. And how do you solve? Well, power down. In this case, both sides power down. Lucky for us, when we take the ln of both sides, the powers are going to come down by the rule that I just wrote earlier. Okay? Now here I use ln, but if you want to use log, I'm okay with that. You can. Sure you can. Let me take the log of both sides, okay? So here we go. Log base 10 of 7x minus 1 equals log base 10 of 3 to the x plus 2. And now by that rule that I wrote earlier, power down, it becomes a coefficient. Power down, it becomes a coefficient. By that rule. Because as a binomial, you better write it within parentheses when you bring it down. So x minus 1 parentheses log base 10 of 7 equals x plus 2 within parentheses log base 10 of 3. And now look, if you're going to solve for this x, which is the same x there, you better get them together. You better get this x and this x together on the same side. But the problem we're having is that this x is in this house and this x is on the other side on a different house. The way to get them together is to get them out of the house. I need to get this x out of this house and I need to get this out of this house. And how do you get to, I mean, when I say out of the house, I mean you need to get rid of the parentheses. I need to get this x out of the house, meaning get rid of parentheses. How do you get rid of this parentheses? Distribute the log. Distribute. Distribute. So we get, by distribution, don't forget, this is just a decimal. What is a decimal? Okay? What is log base 7? That's just a decimal, guys. Don't let that fool you, okay? That's just a decimal. 7, and then, where's the log at? Log, that's 0.8, that's 0.85. This is 0.85. But you don't write it yet. No, not yet. Until the end, because if you write it now, you're losing exactness. What if we want the exact answer? So do not write 0.84 there now, no. Get the approximation at the end. So distribute x log base 10 of 7 minus log base 10 of 7 equals x. This x come out, okay? You better come out of this parentheses by distribution. Log base 10 of 3. Log base 10 of 3, that's just a decimal. Plus 2 log base 10 of 3. That's beautiful, look. This is a term with x. This is just a decimal, guys. And that's just the decimal. What do we say this was? So this is 0.85x. This one, because this is 0.85. But let's not write it now, okay? Because if you do it now, you're losing exactness. Okay? And so that's just a decimal times x. But what we can do is write this term and this term. Now we're going to get them together. Yeah, they go together now. You see, this x was liberated. this X was liberated from the house. This X was liberated from the house. Now they are free. And because it is free now, and this one is free, I can move this one to the left. I couldn't do it before. I could not move this X. I could not do anything with it because it was not free, but it's been liberated. Emancipation. That's what I heard. Okay. So this one has been liberated right there, and so come over to my left. That's beautiful. So this is X log base 10 of 7. Come over. Minus X log base 10 of 3. That's beautiful. Bring this. That's just a decimal. Without this is just a constant without a variable. Bring it over there. It becomes plus log base 10 of 7 plus 2 the log base 10 of 3. That's where we are. Okay, now the problem is now, okay, wait a minute. I want to solve for X, but I have this X and I have this X. I need a single X. To solve for X, I need to do something about it. How can this become an expression with a single X? Easy. Factor out an X. Yes, from this left-hand side, take out the X. Watch this. So this is X times log base 10 of 7 minus log base 10 of 3, close it, equals to log base 10 of 7 plus 2 the log base 10 of 3. And now I have a single X. Now I can solve for X. Divide both sides by this expression right there. So divide this by log base 10 of 7 minus log base 10 of 3. Divide this by log base 10 of 7 minus log base 10 of 3. And this one cancels that one. Yes, it does. Don't say no, say yes. And so, now that we have solved that already practically. So now we have X equals to log base 10 of 7 plus 2 times log base 10 of 3 divided by log base 10 of 7 minus log base 10 of 3. And you have solved. And this is the exact answer. Sometimes professors want you to be able to solve without giving the approximation. We want the exact answer. This is all we want. And so if you make this a decimal at this step right here, you're not going to get this answer. Okay, so what you do is you get to this answer and now you can approximate. So X is approximately equal to, let's do this part right here. I'm gonna do the top first. I better use parentheses. In my calculator, I'm gonna use parentheses and parentheses there. Okay, I may have to use parentheses and parentheses here. So here's what I'm gonna do. Turn it on first. Okay, I'm gonna say log base 10 of 7. I'm gonna say 7 the log, plus, let's see if this works, 2 times, I don't know if it's going to work. Now let me see it. Let me do it all over again. Let me do this part first, okay? I'm going to do this part first. I'm going to say 3 the log. Now times 2 times 2. Got it. Oh, I didn't need this parentheses. I don't, because no, I don't need parentheses. I don't need this parentheses, okay? Some of you may have to, but the way I'm doing it, I don't have to. Okay. Okay, so let me do it again, just for you guys. So 3 log times 2 plus 7 the log equal. Okay, I get 1.3. Let me do it again. Again. 3 the log times 2 plus 7 the log equal. Oh, I had it wrong earlier then. Now I get 1.79. 1.8. I'm going to do it one more time the last time, okay? I get 1.8. 3 the log times 2 plus 7 the log equals, I get 1.8 in the top. If you want to write down, you can. You don't have to. Because now you can say, now let's do the bottom. The bottom, you need parentheses. Divided by. Parentheses. Divided by. Parentheses. 7 the log minus 3 the log, close parentheses, equals. I get 4.9. 4.9. Okay. 4.9. To check, because see, my phone calculator is not a good one. Okay. But to check, you can do this, look. 3 the log times 2 plus 7 the log equal 1.9. The top is 1.8. Divided by, do the bottom. Okay, you can do that too, okay? I have no choice. Because of my calculator is not a very good one, I'm gonna say 7 the log minus 3 the log equals. In the bottom I get 0.37. And now divide. Better get close to this. 1.8 divided by 0.37 equals, I get 4.9. So this was right. Okay. My calculator is not a good one in my phone. Okay. Okay. So these are exponentials. Let's do logarithmic equation. Logarithmic equations, good class. Okay, so for exponentials, we set power down. For logarithmic equations, we say variable out. Okay? Instead of power, you can write variable because the variable is in the power. Okay, so you better say variable down. You can say variable down for exponential equations. For logarithmic equations, you're going to say variable out. Okay, so for exponential equations, you say variable down. For logarithmic, for logarithm equation, you say variable out. Okay? And here's what I'm talking about. Here is a logarithmic equation. Okay. Here. Log base 2 of x minus 3 equals -1. There is your logarithmic equation. Look! You see this variable is part of this binomial. If you're going to solve, you need to get this binomial out from the logarithm. So variable out. For logarithmics, you need to say variable out. Variable out. It needs to come out from the argument of the logarithm. Yes, it does. Okay, how do you get it out? Okay, how do you get it out? There's different ways. Here's what I use. Here's what I always use. Remember what we said earlier. Logarithms are exponents. This logarithm, all this logarithm, this is a logarithm right here, equals to -1. So this must be an exponent because this is equal to a logarithm. Okay, so watch this. Log base b of x equals to y. This logarithm equals to an exponent. This is the base. This base to this power gives you the argument. Let's write that down. How's that? Log, I'm going to write here base. I'm going to write here argument equals to, and I'm going to write here power. Okay? And you see, if you want to make this logarithmic expression exponential, this base to this power gives you the argument. Yeah? This base to this power equals to argument. So this b to the y equals x. B to this y equals the argument x. Base b to the power y gives you x. So therefore, 2 to the negative 1 gives you the argument. Okay. There's another way. Some people, they make this a power and make this a power and give it a base of 2, a base of 2. You can also do that. But I just say 2 to the negative 1 equals the argument. 2 to the negative 1 equals 2, x minus 3. There it is. And so now, variable is out. No more logarithms. Look, variable's out. Variable out. No longer inside. Let's just solve for x. What is x? Bring this to, well, here. X equals 2 to the negative 1 plus 3. And what's 2 to the negative 1? So x equals to 1/2 plus 3. 2 to the negative 1 is 1/2. So therefore, x equals to 2 times 3, 6, 7 halves. And there, we solved. Okay? All right, let's do another one. Let's do another one. Okay. Sometimes the logarithms are very easy, especially if both sides have the same, have a log with the same base. Watch this. Watch this problem. Here's an easy problem. Solve. Solve log base 2, log base, let's make it any base, base 9, yes, base 9, that's what I just said, of 5x plus 14 equals log base 9 of 7x minus 2. Because the only way, if you look at this, everything is the same. Here's the log base 9, log base 9. The only way this is going to be true is if this argument equals to this argument. Okay? So when you have on the left hand side a single log by itself with an argument. And on the right hand side you have a single log by itself with its argument. All you have to do is make the argument equal. Okay, single log here. All by itself, single log. This is its argument. Single log there. By itself, here's its argument. So, conclusion, 5x plus 14 equals 7x minus 2. Now just solve. Bring this to my left. So 5x minus 7x, bring it up to the right, negative 14 minus 2. This is negative 2x equals 2, negative 16, x equals to 8. You know what? You better make sure that this is an answer to this problem, because sometimes the answer is extraneous. What is extraneous? If you were walking on the street and someone came to you and said, "What's an extraneous solution?" your answer is gonna be basura. Basura. Yes, what is basura? Basura is trash. Sometimes the answer is trash to the original problem. Okay? So that's why you need to make sure that plug it in and you get a true statement. Because sometimes the answer is going to give you a false statement or maybe doesn't exist. Okay? So here's our answer. I'm going to check. Let's check, okay? Because you guys have this, right? I got to erase it. I'm going to check. So check the answer and check it up here. 8. What's 5 times 8? 40. What's 40 plus 14? 40 plus 14 is 54. So this is check. On the left hand side, log base 9 of 54 equals log base 9. What's 7 times 8? 56 minus 2, 54. Yes. So it's not extraneous. It's not extraneous. It's not basura. The solution to this is x equals 8. Solution. Let's do one more, okay? Let's do another one. Okay, so take a look at that. Here is one more, okay? So let me erase this. I'm gonna erase this. And right below, I'm gonna write another problem, because I want to compare it to this one. Okay, I'm not going to erase this one. I can erase its answer. Okay. And so now, look, this problem. Here, let us try this problem. I'll just try, for example, this one. I'll try this one. Solve. Log base 5 of x minus 7 equals to 3 minus log base 5 of x. Okay. All right. Look at this problem and look at this one. This one on the left hand side, a single log with its argument. The right hand side, single log with its argument. Because we have a single log and you have a single log, the arguments are equal. And that's what we solve. This one. This one on the left hand side, we have a single log. Yes, here's a single log with its argument. Here we have a single log with its argument, but this is added, this negative log is added to 3, so therefore we cannot say x minus 7 equals to x because of the 3 there. This log is not by itself. Here, this log is by itself, isolated, not here. The 3 is on the way. No problem. Whenever you have this case, okay, well, I cannot say x minus 7 equals to x because of this 3. No problem. I'm gonna get the logs together. I'm gonna get this log and this log together. I'm gonna bring this negative log base 5 of x to my left. So therefore we have log base 5 of x minus 7, bring it over, plus log base 5 of x equals to 3. And now the sum of the logs, if you guys remember this rule, the sum of the logs is the log of a product. So therefore, we can make this a single log. So this becomes the log base 5 of x times x minus 7. There's a rule, okay? And now this is its argument equals to 3. You can put them together. There it is. Okay. Now we have a single log. So we want to solve, we want a log of an expression equals to constant. That way we can use this rule, log base of argument equals to power. You can also say power or constant. Why? Because now you can say this base to this power gives you the argument. So this base to this power gives you this argument. Okay, that's one way. Another way, well, let's do it that way for now, okay? Let's do it that way. So 5 to the third equals x times x minus 7. So 125 equals x squared minus 7x. Okay. Right. Bring it over. So 0 equals to x squared minus 7x minus 125. Okay. Oh, I know why. Okay. All right, we have no choice. I made a mistake. Instead of writing a base of 2, that's why I'm getting this weird answer. Instead of writing base of 2, I wrote base 5. That's no problem. Look, even this, if it looks bad, no problem. You can always use the quadratic formula. Okay? So x equals to negative b. Negative 7, which is 7. Plus minus the square root of b squared. B squared. What's negative 7 squared? 49. Minus 4 times a. What is a? 1. Times c. What is c? Negative 125. All over twice a, 2. The quadratic formula. Okay. So 7 plus minus, so minus b, 7. Plus minus square root of b squared, 7 squared is 49. Minus 4 times a is 1, times c is negative 125. Okay. And now take 4. Negative 4 times negative 4 times negative 125, isn't that 500? So that's 500 plus 49, that's 549. So x equals to 7 plus minus the square root of 549 divided by 2. Okay, lucky for me, I got my calculator and I can check my work. Yes, I can. So 4 times 125, 500 plus 49, okay, equals to, take the square root. Where's the square root? Right there. And I get 23.43 or 7. So this is going to be 23.43. Okay. So this equals to 7 plus minus 23.43 divided by 2. Okay. Now, there are two cases there. There are two cases. The first case is 7 plus. So these are the answers, okay? Answers, the first one. First one is 7 plus 23.43 over 2. That's the first answer. The second answer is 7 minus 23.43 over 2. Okay. Do this one. That one is 30.43 over 2. Okay. So 30.43 divided by 2. I get 15.215. So one answer is x equals to 15.215. How about this one? X equals to, take 23, 7 minus 23.43 equals, divided by 2 equals negative 8.215. So x equals to negative 8.215. Well, guess what? This is an answer to this one. We're talking about the bottom one, okay? Keep going to this one, but this one is gone. We're talking about this one. 15.215, you plug it in there, and you plug it in there, and you're gonna get approximately equal because you have to approximate. But if you plug in this negative, okay, so this one is true. This answer is true. So solution to this, that's an answer. This answer makes it true, a true statement. But watch this. When you plug this here, what's log base 5 of negative 8 minus 7? What's negative 8.215 minus 7? That's negative 15. Negative 15.215. Log base 5 of negative 15, what is it? Error. It's an error. This is not in the domain of this logarithm. So therefore, basura. That's basura. But of course, don't say basura. When you go to a math class, you better not say basura, okay? If you say basura, you didn't hear that from me, okay? You say extraneous. Pick up your color and say extraneous solution. So this is extraneous solution. What does it mean? Basura. And that's the solution. So solution to this. Solution. Solution. $15.215. Most likely, that's fine. Okay. All right, good class. Excellent, everybody. Excelente. I think we're done. Okay. All right, good class. Thank you very much. Okay. You guys have a nice day. And I shall see you